And then 2n squared represents how many what? Electrons. So that's why we got the 2, 8, and 18. You can either memorize it or know that you can just square the principal energy level and then double it, and you've got your number of electrons. Questions? Okay? Now, we're going to do this thing called electron configuration. And when we do electron configuration, what it's doing, it's kind of assigning a address for every electron that you would have. Now, we're not going to, later on, we get to these elements later on, they've got a lot of electrons. So we're not going to worry about every electron. We're really going to just worry about the outer electrons. And so you'll see some similarities in families and their outer electrons and how they compare when we do the electron configuration. So electron is just what it says, how the electrons are configured within the atom. So we start out really easy, and the object is that these electrons always go to the lowest energy possible, combination. So they always go combination-wise that would give them the lowest energy. If you remember, how does an energy of 1 compare to an energy of a 2? Which one has more energy? The 2. And then 3, same as 2. 3 is more energy than 2. When we look at just the sublevels, which one has the lowest energy level of the sublevels? The S. Which one has the highest? The F.
Good morning, Beatrice High School. Good afternoon, actually. This is Mr.
Okay, so we'll start out with the easiest one. Hydrogen has 1 electron in it. And so the progression is these electrons are already there. I kind of make it seem like these electrons are coming in, but they're already in the atom. They're not really coming in. They're there. And so we're just describing where they're at. And so where's the first electron going to be at in hydrogen? It's going to be in the first level. So we're going to write a 1 for that. So what I'm writing now is electron configuration. I'm saying what level that electron's at and what sublevel is it in. It's in the S, sublevel. So it has a sphere shape. Remember I showed you with the balloon, the sphere shape. And that we're going to keep tabs of where those electrons are at by putting a superscript just right above the sublevel. So 1s1. That's the electron configuration for hydrogen. Okay, and it's right here. If we were doing a model of it, there it is. Any questions with that? So then, what's our next element that we would describe?
Helium.
Helium. So helium, where's that next electron go? Now the S can hold how many? 2. And the first energy level can have how many? 2. So that next electron will go here. What do we know about those 2 spins? Maybe some of you guys remember, maybe you don't. What kind of spins will they have? Opposite spins. Very good. So if they're in the same orbital, they have to have opposite spins. So both of them are in the s orbital. And so we would describe that configuration as 1s what? 2. Okay? Does that make sense? So if we're doing s's, the most that they can have is a 2. If we're doing p's, what's the most that they can have?
4.
Nope. There's 3 different types of p orbitals, right? Each of them can hold how many? 2, right? So how many can it have? 6. You guys, what I gave you the other day, you should have kind of an outline of the periodic table. And on that outline of the periodic table, you kind of know what the different sections are at based upon where that element's at. So this is what sublevel? S. There's 2 of them. Then if you count across these, they go 1, 2, 3, 4, 5, 6. Okay? So 1, 2, 3, 4, 5. This is the p's, right? And in here, going across, how many do you have? I'm not going to draw them all out, but how many do you have?
10.
Okay? So there's 10, and that would be the D's. And then down here, you count across, there'd be 14. So these are the F's. So you kind of know where you're at and what you're finishing with. If I would finish in this section, somewhere in this section, my last thing I would write down would be what? D, whatever I count across. So if it's here, that would be D, 1, 2, 3, 4, 5. That makes sense? If I'm right here, then that would be P, 1, 2, 3, 4. P4. It can hold 6. This can hold 10. This can hold 14. And this can only hold 2. 1, 2. Okay? And eventually this will be your map. Because you'll start here. Later on, we won't start there every time. Later on, we'll start at a location over here and pick up from maybe this spot. Because we don't want to show all these they're called inner shell electrons. We don't want to show where those are at. We're only looking at outer shell electrons. Okay? So, let's do nitrogen. I'm not going to do nitrogen. Let's do lithium. So lithium, here's lithium. You guys go ahead and do lithium. We'll see if you get it right. Okay? So, there's 2 electrons. Here's 1 electron. You go ahead and write what you think the configuration is, showing the level of that electron, or those electrons, and the sublevel of those electrons. Just make a good educated guess of what you think the configuration is, and I bet you over half of you will get it right. Think of the pattern, think of the direction that we're going, and we'll see if you get it right. Okay, so we all know that first one's going to be 1s2. Okay? Right? These two don't change. They're going to stay there, and they're going to stay in that 1s from now on, for every element. Every element's going to have the first shell full, past helium, and then we just build on. So then the next level we're going is the 2 level. So what sublevel is being filled? We have to fill in order of energy. So what's lower? Answer P.
S.
An S. So the S has to be filled. So it would be 2s1. Okay? The P's cannot be filled because they're a higher energy than an S associated with it. Alright? So now I'm gonna try to get you to keep on thinking in this trend, how things are going. I'd like you to do nitrogen. Element number 7. You got to account for all the electrons. So okay, so there I have 7 electrons. You got to tell me where all those electrons are located from the inner shell. This is called an inner shell, and this is the outer shell. This 18 shell doesn't exist. It's not there. There's no electrons in it, so it can't exist. So go ahead and see if you can figure out nitrogen and see the progression of it. Now, from what we did here, and I talked about going across the P's, you know that nitrogen is right here, and that should give you an indication of what it's going to end in and how many electrons are in those P's based upon its location within that second column. Okay? You probably should be writing notes down.
Yeah.
Chad. That would be a good thing since you've missed the first 10 minutes of class. I have a pen.
Thank you.
Okay. Who feels confident in their answer? Nobody? Okay. We got anybody else? Did anybody, the last thing they wrote down, you wrote a P, right?
Yeah.
Okay. What do you have in front of the P? 2. That would be right. Because there's a second level. These are in the second level. So now you're going to go 1s2, then 2s2. And that takes it through beryllium. Right? The S's got to hold 2. Remember we said the S's, they have to be completely full before we can go on. So you wouldn't say 2s1 and then go over the P's. You'd make sure you fill the 2s2 up. That's kind of what this shows. You guys see these are kind of paired up. So when we show pairs of electrons within these circles, these are kind of paired up already in their own orbital. That's these s2s. They're kind of like opposite spins, they're paired up. These 3 are in what sublevel? The P. So it'd be 2p, and then what? 3. Any questions? Okay? So let's just look at the back of our periodic table real quick. We're about done with this. I'm going to let you guys work on some things on your lab. Okay, here we go. 1s1, hydrogen. 1s2. The S is filled in the first level. Count across. First level's got 2. Second level has how many? 8, right? 1, 2, 3, 4, 5, 6, 7, 8. Okay? So here's nitrogen. So goes 1s2, 2s2, I'm here. Beryllium. Then 2p1, 2p2, that's carbon. 2p3. Okay? And then so that would be the electron configuration for nitrogen. Make sense? So, last one I want you to do. Now we'll have to do 2 more. This is next to the last one I'm going to have you do. This is what I want you to do. I'm going to go ahead and have you do. I want you to do potassium. No, sorry, sodium. So I want you to do sodium, write out the configuration for all the electrons for sodium. So, look at this. We go in sequence. 1s, 2s, 2p, 3s, 3p, 3d, and so on and so forth. Okay? And then with the superscript, what we're doing is we're telling how many electrons are in that sub-level. That's what we're doing. Now, this can get really, really long and drawn out. And tomorrow I'm going to show you a shorter method to get to your answer, where you don't have to start with hydrogen and 1s1 every time. We can start at a 1 lower on the list, and it's called the abbreviated electron configuration. So we're telling where all these electrons are at. For sodium, there's 11. 2, there's 8 there, and there's 1 there, now that's up to 11. So here we go. 1s2. There we go. Then we go 2s2. That would be one of these pairs. And then we go 2p6. The p's can hold 6. Okay? And then we'll go to the third level. And what starts the third level? S. 3s1. 3s1. So then, if we add these together, 2, 4, 6, 10, and 11. Okay, I want you to look at hydrogen, lithium, and sodium. What do they all end in? S1. So if I had to predict what potassium would end in, you would say S1, but what level? 4S1, right? 1S1, 2S1, 3S1, potassium is 4S1. 5S1. Okay, does that make sense? Okay? Every column has the same ending, just different levels. So this is the last one we're going to do. You're going to do phosphorus. So that's the last one we'll do today is phosphorus, and then we'll review a little bit tomorrow. So go through, starting with hydrogen. Phosphorus is element 15. You have to account for 15 electrons. So a lot of chemistry is patterns. Repeating patterns. That's what periodic means. Repeating patterns. Periodic. It happens periodically. Kind of like a calendar. Sundays every, 8th day is going to be the next Sunday. Okay? Or 7 days, depending upon where you're starting. So the calendars all line up. Yeah, your periodic table is your map. You will automatically look at your periodic table to do all of these in the future because they're your map. You just have to know where you start that map and where you're going to finish. Okay. So, first of all, to see if you did it right, you should look at nitrogen, and nitrogen and phosphorus should end in what? P3. Right? Both of them should end in P3 because they're in the same family. So phosphorus, we go along, we go 1s2, 2s2, 2p6. The second level's filled. Then we go 3s2, 3p3.
Dude, I got it. Dude. That's not that.
Okay. Now, you think you have it, and then tomorrow I'm going to goof you up. It's not because I have to goof you up. It's just because when we take a look at where some of these other ones come in, the pattern's kind of disrupted, and then it creates another pattern later on, which is pretty easy to figure out. Okay, you've got your lab. We are going through 2 sections in Chapter 5. 5.3. Well, actually, right now, Electron Configuration is going through 5.4 and 5.5 is what we're going through. Okay? So if you want to look ahead and kind of see, they do a really, really good job of showing you all the examples up through, quite a ways up through periodic table. If you would go ahead, your